This tool is designed to be used by elite universities in their efforts to effectively match roommates among their incoming class. Each student will first fill out the Personal Habits and Preferences survey shown here. The survey has two sections. The first section asks about personal habits, including wake and bedtime, cleanliness, study habits, alcohol consumption habits, and free time activity preferences. The second section of the survey lists 6 attributes of their prospective roommate. The student is asked to rank these attributes depending on how important it is that their prospective roommate is similar to them in these categories. The ranking is on a scale of 1 to 6, 1 being the most important. After the student completes the survey, he will click the Insert button and his choices will be stored in a database. When we go to the database, you can see that Nikolai's responses have been recorded. Once in the database, the student's responses will be given a numerical score. For the Personal Habits section, each response will be given a score of 0 to 4. For example, if the student indicates that he goes to bed before 11 p.m., he will receive a score of 0. The VLOOKUP function is used to match each student's personal habits choices to a corresponding score in the lookup table. The student's prospective roommate preferences are also allocated a weight, depending on how each factor was ranked. These weights are generated by a cubic function. This is because individuals most often feel very strongly about their first and last choices, in this case the factors ranked 1 and 6. On the other hand, the distinction between one's middle preferences, in this case factors ranked 2 to 5, tend not to be as strong. The cubic function and subsequent allocation of weights is designed to resemble this tendency. The VLOOKUP function is also used to match each student's roommate preferences with the corresponding weight, depending on the ranking of that factor. The Populate button is then clicked and the roommate matrix is populated. This step will take a few minutes, so we'll skip ahead. Each cell is populated with a compatibility score between two students to which that cell corresponds. A student, of course, cannot be matched with him or herself, so those cells are populated with a dummy variable value of 5. Each compatibility score is calculated with an equation taking into account the numerical representations of each student's habits and preferences. The absolute value of the difference between each student's personal habit score for each factor is first calculated. For example, if student A's bedtime score is 1 and student B's bedtime score is 4, their absolute value difference for the bedtime factor is 3. A smaller output indicates stronger similarity in habits between the roommates. A preference score, referred to as a weight, is also calculated for each factor. The weight of a student is added to their counterpart's weight for a given factor, and this weight will then be multiplied by the pair's absolute difference in habits. This process is then repeated for each factor and subsequently added together to generate an overall compatibility score for the pair. Each cell is thus populated with the calculated compatibility scores. As you can see, the matrix is color-coded, with green indicating a more favorable match. After the matrix is populated, an advanced version of the solver tool called OpenSolver is utilized to optimize the roommate compatibility scores, thereby ensuring optimum theoretical roommate satisfaction. This advanced tool is utilized because it allows for a greater number of student inputs than Excel's default solver tool. A separate matrix is referenced, with each pairing cell being considered as a decision variable. If the two students are matched, the cell will be populated with a value of 1. If the students are not matched, the cell will be populated with a value of 0. In order to complete this part of the step, the user will push the Optimize button in the top left-hand corner. This step will also take a few minutes, so we'll skip ahead again. These decision variables are contingent upon solver minimizing the objective function, which is a linear combination of the compatibility score of each cell with the yes-no match value of the corresponding cells. To ensure that there is a perfect one-to-one match among all students, in other words, a student is not matched with more than one other student, this tool includes constraints. Both the row and column corresponding to each individual is only permitted to equal a value of 1, meaning they are matched with exactly one other student. Additionally, each decision variable is constrained in that they can only take on a binary value of 0 or 1, resembling the yes-no nature of the roommate match decision. As previously mentioned, the cells containing a 1 indicate that the students corresponding to that cell are indeed matched. The ultimate roommate match list is generated based on these values. Using the index function referencing the decision variable matrix containing values of 0 or 1, the match list is generated. This is where the student will look to find his or her new roommate. To find their roommate, the user will click the Find Your Roommate button, enter his or her name, and then click Find Roommate. As you can see, Nikolai has been matched with Ruth. This tool will be used by many universities in order to tell the rest of their students as well which roommate their student has been matched with.